Once again, a repeat of clear skies. So there's not going to be much to show you from the air. But we'll go to the surface map, and we do have Tropical Storm Eta moving out of northeastern Florida and up the South Carolina coastline. We'll check on that in just a moment. And we've got a bit of an analysis sandwich as we go north. So let's pull apart the layers of meat and lettuce and see what's going on. Okay, first up is this front here. You can see that that's the leading edge of this cold air coming out of Virginia. Temperatures up in Maryland and West Virginia in the 50s. So the leading edge of that is going to be right there around Myrtle Beach up to Columbia and then down south of Atlanta. And then there's kind of like a vague trace of it maybe all the way down towards western Florida. Now, it's possible you could carry that further west. Certainly we could do that. In fact, that may be the correct solution. But anyway, leaving it at that, this is being driven by high pressure 1021 millibar high across Ontario. You can see that north wind blowing into the Ohio River Basin and the northern Appalachians. Then working our way further up towards the next ingredient is this next frontal system coming out of the plains. That's given us some wintry weather across Minneapolis, 27 there with snow coming down, and looks like heavier snow in northern Iowa. And then working down the front, it warms up very rapidly, upper 50s for Oklahoma. And if you go south of the front, we've got 80s in Texas. This is very hot weather for November. And I can see that we're even up to 88 there near Laredo. And we've got the appearance of a dry line extending from Altus down to San Angelo. And behind that, some very dry air. Here's what it looks like on the surface plot. You can see that cold air coming down into western Oklahoma there. And it's a very shallow cold air mass because it's not making much progress towards Raton or Tucumcari. Then the dry line, where's that located? Well, we got 56 there at Fort Sill, 46 at Oklahoma City. It's actually very dry along that front. I'm probably going to put the dry line from about, I guess that'd be about Altus down to San Angelo and down towards Sanderson, so about like that. East of the dry line, not much moisture, 50s. And it's only in this axis right here where we start getting into 60s. And then as you go on the other side, 40s. So there hasn't been much time for air mass recovery. It looks like the moisture has just come up in the past day or so. In Oklahoma, the moisture axis running about through Duncan and Pauls Valley, 53, and that's it. The visible satellite looking like this. And I see a little bit of built-up cumulus around the San Angelo area, but not much trace of that dry line further north. In fact, it looks like the cirrus spreading over the top of the tropical air has kind of held the temperatures down and suppressed convection a little bit. Does look like a few towers trying to go up around, I guess that would be around Decatur, Texas, Bridgeport, somewhere in there. So, I don't know, there's a little bit of vertical motion, but I seriously doubt we're going to get storms out of that. SPC, not looking for any storms. The high-resolution rapid refresh, looking for some brief showers around Lake Texoma. Okay, so that's one thing that we might have to watch out for, just some high base stuff. The moisture return, very scarce. In fact, let's look at a sounding. Let's back that up right there before convection develops. Bring up a sounding for Gainesville. All right, sounding. It's going to be looking like this here. What do we see? Whatever it is looks kind of high-based. The LCL, anywhere from 1.2 to 1.7 kilometers. That's kind of high-based. Not much instability. Cape is on the weak side. And with the strong wind flow aloft, that's going to dominate the instability. So we're going to get some sheared towers probably. Might be spectacular for time-lapse, but the model not really holding on to any kind of persistent convection. And we can see the leading edge of that front. It's kind of hard to see there on the isobar analysis, but one trick that I sometimes use, I go over to supercell composite, and with that, the boundaries will stand out, but there's just not enough instability for even the boundaries to show up. SRH might help a little bit. Yep, see that right there? You can see the boundary edging down towards Fort Worth. And then the tail end of the boundary running about like that. And you can really see why the area north of a warm front is favored for rotating storms, because you got that strong SRH on the north side. If I bring up a forecast skew-t there in the panhandle, you can see those easterly winds just off the surface. And it gradually rotates around to the southwest. So assuming you're not sucking up too much cold air, if it's kind of a shallow, weak boundary, that's going to be great for rotating storms. But today, yeah, there's not enough moisture to support that. 0 capes. Then further up to the north, we've got this next high-pressure system, and that's what's driving the next front. That high pressure, not particularly cold, 20s and 30s, very common for this time of year, and some of that looks like it's part of this Great Basin high. We'll take a look up to the north and see what's going on in Canada. Not a whole lot, but it does look pretty cold. We've got this very large trough, kind of a broad low-pressure area across the Yellowknife area of Northwest Territories, and kind of connecting into this Gulf of Alaska low. Now what's interesting is that it's very cold in that region, but instead of high pressure, we've got low pressure. So this appears to be Pacific storms kind of working their way inland and dying out. And as the flow aloft begins slowing down, as we get radiational cooling going on, I think we'll start seeing some high pressure starting to build in that area. And then working down south, it looks like we have a lee side trough. Temperatures kind of warm as you go south. We've got 30s there near Calgary. That's kind of warm for this time of year. And as you go further south, gusty winds in Montana. Okay, so that's the wrap-up of surface weather. Let's look at conditions aloft. Now, I always drag out these Canadian analysis charts because these are very unique. We're looking at the actual radiosonde data. See all those plots there in the US and Canada? That was actually observed this morning by balloon-based instruments. And we also get some of the ACARS plots, the AMDAR, the airliner-based measurements in the upper atmosphere. Those go into the models, and there we can see a few of those that make their way into the analysis. So we're actually looking at the raw data. This is not model data. I do think some of the fields, they probably do come from the model. So there's a little bit of hybridization going on. But anyway, besides that, this is a great picture for seeing what's happening in the atmosphere. It's a bit of the best of each world. So we've got a very active jet there in the North Pacific. I can see 201 knots. So you're going to have a long flight flying from San Francisco to Tokyo, assuming you could even get out with all those COVID restrictions. Quite a headwind, and that's going to add hours to your journey. Then looking down into the southern U.S., it looks like we have an active jet stream through that area. 137 knots there at 250 millibars. So that's centered over Colorado. And the axis, looks like there's two axes right there. One across southern Arizona, that's got the look of a subtropical jet. This looks like a polar jet, and it connects all the way up into Quebec. And let's see, am I missing anything? Yeah, maybe the subtropical jet segment extends a little bit like that. That's a possibility. Yeah, those are coupled, polar and subtropical jet. And then up to the north, we can see weak winds aloft. So I think because of that, I think we should be seeing that cyclogenesis starting up. I've got to take a look at the models. Let's check that out. Okay, so there's the low pressure there. That's the two lows that we saw on the surface chart. What is this thing? Okay, I don't know what that thing is, so just ignore it. So moving forward, yeah, there it is. There's the high pressure starting up, building in. So I think now we're starting to get that radiational cooling taking effect. 1022 millibar high there by Monday. And I can see that starting to nose into the Canadian prairies. This is all a big high pressure area. And let's see if that makes it very far south. Yeah, it slides into the Great Lakes and the Ohio River Basin, but it's broken up by this very strong cyclogenesis out west. And I think we're starting to get maybe the Pineapple Express starting up. Let's check that out. And for the Pineapple Express, we want to look at the precipitable water. So to get that Pineapple Express going, we're going to have to tap into this stuff down here. Let's see. Moving into Saturday, Sunday, I can see it's active there in the northwestern U.S. And yeah, here comes a plume right there, Monday. I can see that working into the western U.S. Yeah, so I think about the best we're going to do is Wednesday and Thursday. It looks like some moisture coming into northern California and Oregon right around that time. Well, guys, I don't know how we ended up with 12 minutes and 15 seconds of content. Either there was good stuff to talk about or I was rambling too much, one of the two. But we'll see if we can pick up this dynamics lesson here. We're going to talk about tilt of fronts and how they appear on constant pressure charts. Well, I would say we've got ourselves a good guinea pig. There's a cold front right there coming down through the Central Plains. We saw that on that Texas-Oklahoma chart. So let's do a cross-section running from about western Nebraska down towards southeastern Oklahoma, maybe all the way to Shreveport. So we're going to definitely cut through that front right in the middle. And it's definitely a weak front, but I can barely pick it out there. So that runs about from Oklahoma City up towards the Nebraska-Kansas border. And so up that far north, it's going to be above 500 millibars. So that puts the 500 millibar upper front right about there over Kansas. The 700 millibar upper front looks to be maybe in southern Kansas. And the 850 millibar front would be over northern Oklahoma. And you can see that as you go up higher with height, the fronts tend to be found further and further back towards the cold air. And that's a quality that we often find with upper level fronts. In fact, we always find it that way with upper level fronts. That's a rule of thumb. So starting out with surface temperature, that's going to be the leading edge of that cold air, pretty much right over Oklahoma City. Let's go up to 850 millibars, 5,000 feet. The 850 millibar front, that's going to be maybe just a tiny bit north of Oklahoma City. Right in that area, you can see the northerly winds north of that 850 front, and the temperature gradient falls all the way up towards Nebraska. Let's go up to 700 millibars, 10,000 feet. And there we find the 700 millibar front pretty much right on the Kansas-Oklahoma border, right about there. The winds turn to the west. And let's go up to 500 millibars. And the 500 millibar front, it's a little bit more indeterminate, but it looks like it's going to be somewhere right in there. The gradients look to be very, very strong there north of I-70 and very weak down to the south. But we are picking up another gradient out here, and that's what's supporting the subtropical jet. That's further up in the troposphere. So let's go down to 850 millibars. Remember, the front is down in this area. Would you say the wind component is from cold to warm or from warm to cold? How about at 700 millibars? Is it from cold to warm or from warm to cold? Seems like in both cases it's pretty much flowing from cold air to warm air, and that's the definition of a catafront. The component of motion across the front is mostly towards the warm air. So if we look at a cross-section across the front once again, and we look at the component of motion in the plane of the diagram, in other words, left and right rather than into the page and the other way, we see that the wind component is positive. Positive is to the right, so there's a tendency for the air to flow from left to right, and that's a good example of a catafront. The winds, they tend to cling to the isotropes, which we see right here. You can see that they slope downwards. So we're favoring subsidence, isentropic descent, and this tends to bring us clear weather, or at least good weather, and an absence of clouds or a tendency for the clouds to clear out. Here's another good example of a catafront. This is going to be the front moving across the central U.S. Saturday night. Very powerful front there. And if we do a cross-section from the cold air to the warm air, look at the in-plane wind, we can see that there's a very strong component of motion along the frontal surface. So the front is located about right there, and you can see that red there indicating 50 to 60 knots towards the right. So there's going to be descent along these isotropes. That doesn't mean that you can't get precipitation. You can have lots of convection back here behind the front or even along the front, but you're not going to get widespread stratiform rain areas. Even though that's what it appears to be showing here, if we go to pivotal weather for the same time, we can definitely see that these precipitation fields look to be more convective and not stratiform like what you see up in this area here. The Anafront, that's the opposite. I don't have a good example of that, and we're running short of time, but that's going to be the opposite. That's going to be where the wind component is mostly towards the left or from warm to cold. And you'll get isentropic ascent. Katafronts come from the word kata, which means downward. Kind of resembles katabatic winds. So catafront, that's a downward moving front, sort of. And it also has the name inactive front. Inactive. The opposite, anafront, that's called an active front. You'll see that in a lot of references. With anafronts, the upper level flow. With anafronts, the wind flow tends to closely parallel the front. But with catafronts, like what we have today, usually the upper level winds kind of impinge on the front at an angle, say from 30 to 60 degrees. Okay, and that's all I got for this edition of Forecast Lab. Hope you enjoyed it. Please comment, like, and subscribe, as they say. And we'll see you tomorrow for the Friday edition. Take care. Bye-bye.